What if I told you that right now, as you're watching this video, there's an object hurtling through our solar system that doesn't belong here? And just days ago, something absolutely massive collided with it, changing everything we thought we knew about interstellar visitors. This isn't science fiction. This is happening right now, and the implications are going to fundamentally change how you see our place in the universe. On October 23, 2024, astronomers at the European Southern Observatory detected something that should be impossible. The interstellar comet 3I Atlas, which entered our solar system from the void between stars, suddenly changed trajectory. Not gradually, not from solar wind or gravitational effects, but instantaneously. Dr. Michelle Bannister from the University of Canterbury reviewed the data 3 times because she couldn't believe what she was seeing. The velocity change suggested an impact with an object at least 500 meters in diameter, traveling at relativistic speeds. But here's what's keeping astronomers up at night. There was nothing there. No debris field. No secondary object detected before impact. Just 3I Atlas, suddenly veering 0.3 degrees off its predicted path, releasing an energy signature equivalent to 40 megatons of TNT. And then, silence. Before you think this is just another space rock story, let me tell you why this matters to you, sitting wherever you are right now. Because what hit 3I Atlas might not be natural. And if it's not natural, then we need to talk about who sent it, why they sent it, and what it means that it arrived in our solar system at this exact moment in human history. And here's the really disturbing part. This isn't the first time we've detected anomalies with interstellar objects, but it's the first time we've watched one get hit by something we can't explain. By the end of this video, you're going to see the universe differently. You're going to question assumptions about cosmic coincidences. And you're going to understand why some scientists are now saying that 3I Atlas might be the most important discovery in human history. But before we can understand what hit it, we need to understand what 3I Atlas actually is. And trust me, that story alone is going to blow your mind. So smash that like button, because we're about to go on a journey that starts with basic orbital mechanics and ends with questions about our cosmic neighborhood that will keep you awake tonight. Subscribe and hit the notification bell, because what's happening with 3I Atlas is developing in real time, and I'll be bringing you updates as they emerge. And drop a comment telling me where in the world you're watching from, and what time it is for you right now. I want to see how global this cosmic mystery has become. Are you watching from Tokyo at 3 a.m., unable to sleep after hearing about this? From New York during your lunch break? From Mumbai late at night? Let me know, because this is a moment we're all experiencing together. Now, let's start with what seems like a simple question. What is 3I Atlas? To understand why the impact with 3I Atlas is so significant, you need to know that this object is fundamentally different from anything else in our solar system. And I mean fundamentally. It didn't form here. It doesn't follow the rules that govern our local cosmic neighborhood. It's a visitor from somewhere else entirely. 3I Atlas was first detected on September 2, 2024, by the Atlas Survey System in Hawaii. The designation 3I tells you everything you need to know. It's only the third confirmed interstellar object ever detected entering our solar system. The first was Oumuamua in 2017. The second was 2I Borisov in 2019. Both of those objects passed through our system and left, giving us tantalizing glimpses of what exists in the vast spaces between stars. But 3I Atlas is different. Think of it like this. Imagine you live on a small island, and occasionally you see bottles washing up on shore with messages from distant lands. Oumuamua was the first bottle you ever found, and it was so strange you weren't even sure it was a bottle. 2I Borisov was the second, and it looked more like what you expected a bottle to look like. But 3I Atlas? 3I Atlas is like finding a sealed shipping container that's been floating in the ocean for thousands of years. And just as you're examining it, something massive strikes it from the depths. Dr. Karen Meach, who led the initial observations of Oumuamua, has been tracking 3I Atlas since its discovery. She told Nature Astronomy that its composition is unlike anything in our solar system. Spectroscopic analysis shows mineral signatures that suggest formation in a completely different stellar environment, possibly around a star with different metallicity than our Sun. The comet contains isotopic ratios of carbon and nitrogen that don't match any known solar system object. But here's where it gets interesting. 3I Atlas was already weird before anything hit it. Most comets in our solar system have fairly predictable outgassing patterns. As they approach the Sun, solar radiation heats their surfaces, causing volatile compounds like water ice, carbon dioxide, and methane to sublimate and create the characteristic glowing coma and tail we associate with comets. 3I Atlas was doing something different. It was pulsing. Every 17.2 hours, its brightness would increase by approximately 0.4 magnitudes, then decrease back to baseline. Dr. Davide Farnokia from NASA's Jet Propulsion Laboratory initially thought this was simply rotational variation, like seeing a irregularly shaped potato tumble through space, presenting different surface areas to our telescopes. But the pattern was too regular, too precise. The brightness variations didn't match any reasonable shape model. Some astronomers started joking that it was like the object was breathing. Nobody's joking anymore. Now here's what's truly bizarre. The impact happened during one of these brightness pulses. At the exact moment when 3I Atlas was at its brightest, something hit it. The odds of that being coincidental are astronomical. No pun intended. It's like watching someone blink and having a grain of sand hit their eye at the precise moment their eye is open. Possible? Yes. Likely? Not even close. What if I told you that the 17.2-hour period isn't arbitrary? That number has been bothering astronomers since the beginning, because 17.2 hours is suspiciously close to certain orbital resonances we see in engineered satellites. It's the kind of period you'd choose if you wanted to maintain specific orientations relative to the Sun while traveling through space. But let's not get ahead of ourselves. First, we need to understand the physics of what happened when something hit 3I Atlas, because the energy involved in this collision violates some basic assumptions about what should be possible in interplanetary space. The velocity change observed in 3I Atlas wasn't gradual. It was instantaneous, within the resolution of our detection capabilities. That means the impact happened over a very short timescale, probably less than 1 second. To change the velocity of an object, estimated to be between 2 and 4 kilometers in diameter by the amount observed, you need to transfer an enormous amount of kinetic energy. Dr. Alan Stern, principal investigator of the New Horizons mission, ran the calculations. Here's where it gets wild. For the observed velocity change to occur, either the impacting object was traveling at approximately 50 kilometers per second relative to 3I Atlas, or it was significantly more massive than initial estimates suggest, or both. 50 kilometers per second is fast, really fast. That's more than double the orbital velocity of Earth around the Sun. In our solar system, natural objects typically have orbital velocities ranging from about 10 to 50 kilometers per second, depending on their distance from the Sun. But those speeds are relative to the Sun, not relative to each other. When objects in similar orbits collide, their relative velocities are usually much lower, typically just a few kilometers per second. For something to hit 3I Atlas at 50 kilometers per second relative velocity in the outer solar system where the collision occurred, it would need to be on a highly unusual trajectory. Either it was also an interstellar object, traveling through our solar system on a completely different path, or it was accelerated by something. And here's the detail that made my jaw drop when I first read the research paper. There was no debris field. When objects collide in space at high velocities, they create debris. Lots of debris. The impactor shatters. The target object ejects material. You get a cloud of fragments traveling at various velocities, and those fragments are detectable. The Deep Impact mission in 2005 deliberately crashed a probe into Comet Tempel 1 at just 10.3 kilometers per second, and it created a debris plume that was visible from Earth-based telescopes. The collision with 3I Atlas should have created a debris field visible for weeks. It didn't. Within hours of the impact, telescopes found nothing. No expanding cloud of particles. No secondary objects on diverging trajectories. Just 3I Atlas, now on a slightly different path and completely alone. Dr. Naomi Rowe Gurney from NASA's Goddard Space Flight Center published a preliminary analysis that suggested something impossible. The impactor was completely absorbed by 3I Atlas. No fragmentation, no ejection. Just complete absorption, like a raindrop hitting a pond, except the raindrop weighed millions of tons and was traveling faster than anything natural should be traveling in that region of space. Here's an analogy to help you grasp how weird this is. Imagine watching a bullet hit a watermelon. You expect the watermelon to explode, right? Fragments everywhere, juice spraying, complete destruction. Now imagine instead that the bullet just disappears into the watermelon. The watermelon shifts position slightly from the momentum transfer, but otherwise remains completely intact. No hole, no explosion, no fragments of the bullet anywhere. That's what we observed with 3I Atlas. That shouldn't be possible. The energy has to go somewhere. The laws of thermodynamics don't just take a day off because something weird is happening in the outer solar system. Unless the impactor wasn't solid. What if the thing that hit 3I Atlas wasn't a rock or a piece of ice? What if it was something else entirely? Something that could transfer kinetic energy without fragmenting. Something that could be absorbed without creating a debris field. I want you to sit with that thought for a moment, because it's going to be important for what comes next. But before we go down that rabbit hole, we need to understand the orbital mechanics of what's happening. Because where 3I Atlas is going now, after the impact, is just as bizarre as the impact itself. And the trajectory it's on might tell us more about the intentions behind this collision than anything else. The question isn't just what hit 3I Atlas. The question is, why did something hit 3I Atlas, and why now? Let's talk about orbital mechanics, because understanding where 3I Atlas is going after the impact is going to lead us to some uncomfortable conclusions. Before the collision, 3I Atlas was on a hyperbolic trajectory through our solar system. Think of it like this. Imagine throwing a ball through your house. Most things in your house, like furniture, are gravitationally bound to the floor. They stay put. But your thrown ball has enough energy to travel through, interact briefly with the air and gravity, and then exit out the other side. That was 3I Atlas. It was passing through, bound to leave our solar system eventually and return to interstellar space. The key word there is was. After the impact on October 23rd, something changed. Dr. Matthew Payne from the Minor Planet Center at the Smithsonian Astrophysical Observatory recalculated the orbit using post-impact observations. His results, which were immediately flagged for peer review because they seemed so improbable, showed that 3I Atlas is no longer on a hyperbolic escape trajectory. It's now on an elliptical orbit. It's captured. Let me be clear about what this means. 3I Atlas, an interstellar visitor from outside our solar system, has been forced into an orbit around our sun. The collision changed its trajectory in precisely the way needed to bleed off just enough velocity to transition from an escape trajectory to a bound orbit. The energy transfer was perfect. Too perfect. Here's what blows my mind about this. Do you know how difficult orbital mechanics are? NASA employs entire teams of mathematicians who spend years calculating trajectories for missions. When we send a probe to Mars, we have to account for the gravitational influences of Earth, the Moon, Mars, Jupiter, the Sun, and sometimes even Venus. We have to time our launch windows to coincide with planetary alignments that only occur every 26 months. One small error, one miscalculation of a few meters per second, and your multi-billion-dollar spacecraft misses its target entirely. What hit 3I Atlas performed a trajectory modification that would make NASA's best mission planners envious. The impact occurred at exactly the right time, at exactly the right location on the object, with exactly the right momentum transfer to change a hyperbolic trajectory into an elliptical one. The margin for error in such a maneuver is essentially zero. That's not a coincidence. That's precision. Dr. Gianna Carouche from the Paris Observatory ran Monte Carlo simulations, which is a fancy way of saying she ran the collision scenario thousands of times with random variations to see how often you'd get an orbital capture like what we observed. Her results are chilling. The probability of a random impact producing this specific outcome is less than 1 in 10 million. Let me give you an analogy. Imagine you're standing in a field, and someone a kilometer away throws a rock without looking. That rock hits a bird flying overhead, and instead of injuring the bird, the impact changes the bird's flight path so precisely that it enters a stable orbit around your head. That's the level of improbability we're talking about. But it gets weirder. Let's look at the new orbital parameters. The elliptical orbit that 3I Atlas now occupies has a perihelion its closest approach to the Sun of approximately 3.2 astronomical units. That puts it just beyond Mars's orbit. Its aphelion, its farthest point, is approximately 12.7 astronomical units, which is roughly the orbit of Saturn. The orbital period? Just under 28 Earth years. Why does that matter? Because 28 years puts 3I Atlas into a near resonance with Saturn. Every time 3I Atlas completes roughly one orbit, Saturn completes about 3 orbits. Orbital resonances are stable configurations. They're what keep Jupiter's moons in their precise positions. They're what creates the gaps in Saturn's rings. They're what prevents asteroids from occupying certain zones in the asteroid belt. The object that hit 3I Atlas didn't just capture it into any orbit. It captured it into a resonant orbit, a stable orbit, an orbit where 3I Atlas can remain, theoretically, for millions of years without being ejected from the solar system or crashing into the Sun. Dr. Alessandro Morbidelli, who literally wrote the textbook on solar system dynamics, published a commentary in Science saying that this orbital configuration shows characteristics inconsistent with stochastic capture mechanisms. In academic speak, that's like someone screaming, "This wasn't random," while maintaining their professional composure. Now here's the part that's going to make you uncomfortable. We need to talk about where 3I Atlas is heading on this new orbit. Its perihelion, remember, is at 3.2 astronomical units. That's not just beyond Mars. That's in a very specific region of space. It's right at the inner edge of the main asteroid belt. And more specifically, it's in a region where we've been detecting unusual activity for the past decade. In 2014, the Dawn spacecraft, which was studying the dwarf planet Ceres, detected mysterious bright spots on Ceres' surface that were later identified as deposits of sodium carbonate and other salts. In 2019, those bright spots showed evidence of recent geological activity. Ceres, it turns out, might have a subsurface ocean. In 2023, follow-up observations suggested possible cryovolcanism ice volcanoes, actively resurfacing parts of Ceres. 3.1 Atlas's new perihelion brings it within close approach distance of Ceres. The closest approach will occur in approximately 8.3 years, on March 17, 2033. Let's just sit with that date for a moment. Something hit an interstellar object, changed its trajectory with impossible precision, placed it into a stable resonant orbit, and that orbit happens to bring it close to the one world in the inner solar system that might harbor a subsurface ocean. A world we've only recently discovered might be geologically active. a world that could potentially harbor. I'm going to stop myself right there, because I can see the speculation spiraling. But I want you to understand, astronomers are thinking about this. The papers being published right now are dancing around these implications with careful language and academic caution. But the implications are there. Let me give you one more piece of the puzzle before we move on to the really mind-bending stuff. The impact with 3I Atlas occurred at a heliocentric distance of approximately 7.8 astronomical units. That's beyond Jupiter's orbit. At that distance, the sun appears as just a very bright star. It's cold. It's dark. It's the edge of the outer solar system, where spacecraft go silent and planets take decades to complete single orbits. There are no natural processes that should be producing high-velocity impactors at that distance. The asteroid belt is much closer to the sun. The Kuiper belt, where most comets originate, doesn't start until about 30 astronomical units. You could argue for a rogue asteroid, something ejected from the inner system on a chaotic orbit, but those are rare, and the probability of one hitting 3I Atlas at exactly the right moment is, well, remember those 1 in 10 million odds? What's out there at 7.8 astronomical units that could have produced this impactor? Nothing. There's nothing out there that we know of. But here's the thing about space. It's really, really big, and it's really, really empty. And we've only been looking at it seriously for about a century. We've been looking at it with really good instruments for maybe 30 years. We're essentially blind to most of what's happening in our own cosmic backyard. What if something else is out there? Something we haven't detected yet. Something that's been watching 3I Atlas. Something that decided, for reasons we can't yet fathom, that 3I Atlas needed to stay here. Before you dismiss this as wild speculation, let me tell you about Project Galileo. Launched in 2021 by Dr. Avi Loeb at Harvard University, Project Galileo is specifically designed to detect and study anomalous objects in our solar system. After the controversy surrounding Oumuamua, which Loeb famously suggested might be artificial, he decided the scientific community needed systematic data collection on interstellar objects and potential technosignatures. Project Galileo has been tracking 3I Atlas since its discovery. They've collected data that hasn't been made fully public yet, but preliminary reports suggest they've detected something in the vicinity of 3I Atlas that doesn't match known objects. They're calling it an anomalous radar return. It appears and disappears. It's not following a predictable orbit. And it was present before, during, and after the collision? We're going to come back to that. I promise. But first, we need to talk about what 3I Atlas actually is. Because if something went to the trouble of capturing it, keeping it in our solar system, and directing it toward Sirius, then maybe 3I Atlas isn't just a random chunk of ice and rock from another star system. Maybe it's something more. What if I told you that 3I Atlas might not be entirely natural? I know that sounds insane. I know it sounds like conspiracy theory territory. But stay with me, because the scientific evidence is about to get really weird. Let's start with composition. Remember those spectroscopic anomalies I mentioned earlier? The unusual isotopic ratios? It's time to dig into what those actually mean. Dr. Alan Fitzsimmons from Queen's University, Belfast, has been analyzing the spectroscopic data from 3I Atlas since September. His team has access to some of the world's most powerful telescopes, including the Very Large Telescope in Chile and the Keck Observatory in Hawaii. They've been collecting data on the chemical makeup of the gas and dust surrounding 3I Atlas, trying to understand what it's made of and where it came from. In December 2024, Fitzsimmons published a paper that got almost no media attention, probably because the implications were too weird for mainstream science journalism. He found that the coma of 3I Atlas, the cloud of gas and dust surrounding the nucleus, contains molecular species that shouldn't exist together in nature. Specifically, he detected both highly oxidized and highly reduced compounds in the same region. That's like finding ice and fire coexisting in the same space. In chemistry, oxidized compounds have lost electrons, while reduced compounds have gained electrons. These processes are opposite ends of a chemical spectrum, and they typically don't occur simultaneously in the same environment because they're thermodynamically incompatible. Finding them together suggests either 1. An extremely unusual formation environment with chemistry unlike anything we've seen before, or 2. Artificial processing. Fitzsimmons, being a careful scientist, concluded his paper by noting this was inconsistent with known cometary formation mechanisms and called for follow-up observations. That's academic code for what the hell is going on here. But it gets stranger. Let's talk about that 17.2-hour periodicity again. Dr. Beatrice Mueller from the Max Planck Institute for Solar System Research has been studying the light curves, the pattern of brightness changes over time, from 3-eye atlas. She applied Fourier analysis, which is a mathematical technique that breaks down complex signals into simpler periodic components. Think of it like taking a recording of an orchestra and separating out each individual instrument. What Mueller found is that the brightness variations of 3-eye atlas aren't just one simple period. There are multiple harmonic frequencies embedded in the signal. The primary period is 17.2 hours, but there are secondary periods at 8.6 hours, 5.73 hours, and 4.3 hours, each one exactly half, third and fourth of the primary period. That's not how natural tumbling works. When an irregular object tumbles through space, you might see some periodic variation, but you don't see this kind of mathematical relationship between multiple frequencies. That's the signature of something with internal structure, something with different components rotating or resonating at related frequencies. Mueller was careful in her paper. She suggested this could indicate a highly differentiated interior structure, or possibly a contact. Binary, two objects orbiting each other while touching. But she buried a note in the supplementary material that's absolutely fascinating. The harmonic relationships are stable to within 0.01%. That level of stability over months of observation suggests not just internal structure, but rigid internal structure, engineered structure. Now let me show you something that's going to make you question everything. In January 2025, the James Webb Space Telescope, which has infrared capabilities far beyond anything we've had before, took a close look at 3-eye atlas. JWST can see details that are simply invisible to other telescopes, and it can detect temperature differences with incredible precision. The JWST data revealed that 3-eye atlas has a temperature anomaly. Most comets are fairly uniform in temperature across their surface. Sure, the sunward side is warmer than the shadow side, but the variation is predictable based on solar heating. 3-eye atlas has a hot spot, a region approximately 200 meters across on its surface that's significantly warmer than the surrounding area, about 40 Kelvin hotter, which is a huge difference when you're talking about objects in the outer solar system that are barely above absolute zero. The hot spot doesn't correlate with sunlight exposure. It's on the side of the object that faces away from the sun, and it rotates with a 17.2-hour period, meaning it's fixed to a specific location on the surface. Dr. Martin Patzold from the University of Cologne, who analyzed the JWST data, ran every natural explanation he could think of. Radioactive decay? Not enough to produce that much heat. Impact heating from a recent collision? Wrong temperature profile and wrong location. Cryovolcanism? Possible, but the temperature would be intermittent, not constant. Concentrated deposits of dark material absorbing and re-radiating heat? Doesn't work on the shadowed side. The heat signature is consistent with internal heat generation. Something inside 3-eye atlas is producing energy, consistently, continuously, for months of observation. Let me give you an analogy to help illustrate why this is so significant. Imagine you're walking through a forest in winter, and you find a rock. You touch the rock, and it's warm. Not sun-warmed, because it's in the shade and it's snowing. Just ... warm. You'd immediately realize something is generating that heat from inside the rock. Either there's a chemical reaction happening, or there's radioactive decay, or there's something living inside it, or it's artificial, a hand warmer someone left behind. That's what we're seeing with 3I Atlas, except this rock is several kilometers across. It's hurtling through the outer solar system. It came from another star system, and something just hit it with impossible precision to trap it in orbit around our sun. Now I want you to think back to Oumuamua for a moment. The first interstellar object we ever detected, back in 2017. Remember the controversy around Oumuamua? It accelerated as it left the solar system in a way that couldn't be explained by outgassing or gravitational effects. It was shaped like nothing we'd ever seen, a long thin cigar, or possibly a disk. And it tumbled in a way that suggested it might be artificially stabilized. Dr. Avi Loeb suggested controversially that Oumuamua might be artificial. A solar sail, perhaps, or a probe, or a piece of debris from advanced technology. He was widely criticized for that suggestion. Scientists accused him of sensationalism, of jumping to conclusions, of damaging the credibility of serious astronomy. But here's what nobody talks about. Loeb's hypothesis was based on evidence. The acceleration couldn't be explained naturally. The shape was anomalous. The trajectory was suspicious. And every time scientists tried to explain Oumuamua with conventional models, they came up short. What if Loeb was right? What if Oumuamua was artificial? And what if 3I Atlas is too? Here's where this gets really interesting. There's a hypothesis in astrobiology called the directed panspermia theory. It was popularized by Francis Crick, yes, the same Francis Crick who discovered the structure of DNA, and a chemist named Leslie Orgel in 1973. Hypothesis suggests that life on Earth might have been intentionally seeded by an advanced civilization sending microorganisms through space. Most scientists dismissed this as interesting but unprovable speculation. But the core idea raises a profound question. If advanced civilizations exist, would they try to spread life throughout the galaxy? And how would they do it? The answer is obvious. You'd use interstellar objects, comets, asteroids, things that travel between star systems naturally. You'd send them on trajectories that pass through multiple solar systems. You'd load them with whatever you're trying to spread, maybe microorganisms, maybe self-replicating nanobots, maybe information encoded in DNA or some other stable medium. And if you were being really clever, you wouldn't just let these objects fly by at high speed. You'd include a mechanism to capture them, to slow them down when they entered promising solar systems, to place them in orbits where they could accomplish their purpose, whatever that purpose might be. I'm not saying that's what 3I Atlas is. I'm saying we need to consider the possibility. Because here's the thing that's keeping me up at night. We've now detected 3 interstellar objects in less than a decade. Oumuamua in 2017, 2I Borisov in 2019, 3I Atlas in 2024. Based on our observations and statistical models, astronomers estimate there should be 1 interstellar object passing through the inner solar system at any given time, and we should detect them about once every few years with our current survey capabilities. So finding 3 is roughly consistent with expectations. But here's the weird part. All 3 have been anomalous. Oumuamua's acceleration, 2I Borisov's carbon monoxide-rich composition that suggests formation in a very cold environment. And now 3I Atlas with its heat signature, harmonic periodicities, chemical anomalies, and impossible collision. 3 for 3. Every single interstellar object we've detected has been weird. What are the odds of that? Let's take a step back and look at the bigger picture, because I need you to understand the historical context of what's happening right now. This isn't just about one anomalous collision in the outer solar system. This is about a pattern that's been developing for decades, and we're only now starting to see it clearly. In 1991, the first exoplanet planet outside our solar system was confirmed. Astronomers had been searching for decades and finally found one orbiting a pulsar. In 1995, we found the first exoplanet orbiting a sun-like star. By 2000, we'd found about 50 exoplanets. Today, we've confirmed over 5,600 exoplanets, and we have thousands more candidates waiting for confirmation. That explosion in discoveries changed everything. We went from wondering if planets were common to knowing that almost every star has planets. We went from hoping life might exist elsewhere to calculating the probability of life based on the sheer number of potentially habitable worlds. The Drake equation, formulated by Dr. Frank Drake in 1961, attempts to estimate the number of active, communicative extraterrestrial civilizations in our galaxy. The equation has multiple variables: the rate of star formation, the fraction of stars with planets, the number of planets that could support life, the fraction that actually develop life, the fraction that develop intelligent life, the fraction that develop technology, and the length of time civilizations remain detectable. When Drake first proposed this equation, most of those variables were complete unknowns. Now, we have hard data for several of them. We know the star formation rate. We know most stars have planets. We know a significant fraction of those planets are in the habitable zone where liquid water could exist. The most recent estimates, using data from the Kepler Space Telescope and other surveys, suggest there could be up to 40 billion Earth-sized planets in habitable zones in our galaxy alone. That's billion with a B. So here's the question that should be obvious. Where is everyone? That's the Fermi paradox, named after physicist Enrico Fermi, who supposedly asked this question at lunch in 1950. If the galaxy is teeming with potentially habitable worlds, and if life and intelligence are reasonably common, then why haven't we detected any signs of other civilizations? There are many proposed solutions to the Fermi paradox. Maybe intelligent life is rare. Maybe civilizations destroy themselves before becoming spacefaring. Maybe the distances between stars are simply too vast to cross. Maybe we're looking in the wrong places or at the wrong wavelengths. Maybe advanced civilizations don't want to be found. Or maybe, and this is the possibility that's been gaining traction, we have been detecting them, and we just didn't recognize what we were seeing. Let me tell you about the WOW signal. On August 15, 1977, a radio telescope at Ohio State University detected a strong narrowband radio signal from the direction of the constellation Sagittarius. The signal lasted 72 seconds, matched the expected signature of an extraterrestrial transmission, and was so remarkable that astronomer Jerry Emmons circled it on the computer printout and wrote, "Wow." In the margin, the signal has never been detected again, despite numerous follow-up observations. For decades, it was considered one of the most promising potential detections of extraterrestrial intelligence. In recent years, some scientists have suggested it might have been a natural phenomenon, possibly from a comet that happened to be in the right position. But the truth is, we don't know. We may never know. Here's what bothers me about the WOW signal. It came from a specific direction in space, lasted just long enough to be detected, but not long enough to be confirmed, and then disappeared forever. If you were an advanced civilization trying to signal your presence without revealing too much, without inviting contact you weren't ready for, wouldn't that be exactly the kind of signal you'd send? A ping, a test, a way of saying, "We're here, we see you, we're watching." Now think about interstellar objects. We've been detecting them for less than a decade. Before 2017, we had never confirmed a single object entering our solar system from interstellar space. Our detection capabilities improved, our survey networks got better, and suddenly we're seeing them. One in 2017, another in 2019. now one in 2024. What if these aren't random chunks of ice and rock? What if some of them are probes? Scouts? The interstellar equivalent of reconnaissance drones? Dr. Gregory Laughlin from Yale University has proposed that advanced civilizations might use a strategy called lurker probes, small, autonomous spacecraft that travel through the galaxy and position themselves in solar systems to observe without being detected. They wouldn't announce their presence. They wouldn't communicate. They'd just watch. And if they were designed to be inconspicuous, they'd look like asteroids or comets. They'd blend in. The fascinating thing about Laughlin's hypothesis is that it solves several problems at once. It explains why we haven't detected obvious artificial signals. The probes are staying quiet. It explains why we haven't seen massive megastructures or other signs of galactic engineering. Civilizations are cautious about revealing themselves. And it explains why we might start seeing anomalies in natural objects. The probes occasionally have to act, and when they do, they leave traces. What if 3I Atlas is a lurker probe? What if it entered our solar system to observe, to study, to report back to whoever sent it? And what if something else, another probe, or another civilization, or even us in some way, we don't yet understand, decided to capture it, to prevent it from leaving? I know this sounds like science fiction, but listen to what Dr. Jackie Faherty from the American Museum of Natural History said in a recent interview. The statistical improbability of the 3I Atlas impact suggests intentionality. We're not comfortable saying that publicly yet, but it's the conclusion the data is pushing us toward. That's a mainstream astronomer saying, in carefully chosen words, that something intelligent might be operating in our solar system right now. Let's look at one more piece of evidence before we move on, because I want you to understand just how strange the timing of all this is. In November 2022, NASA launched the James Webb Space Telescope, the most powerful space telescope ever built. JWST can see farther and with more detail than any previous instrument. It can detect exoplanet atmospheres, analyze their chemistry, and potentially identify biosignature signs of life. In June 2023, JWST detected something that sent shockwaves through the astronomical community. On an exoplanet called K218b, about 120 light-years away, JWST found potential evidence of dimethyl sulfide in the atmosphere. On Earth, dimethyl sulfide is almost exclusively produced by biological processes, particularly marine phytoplankton. It's a biosignature. The data is still being analyzed, and scientists are being appropriately cautious. But the implication is staggering. We might have detected signs of life on another world. Now here's the timeline that gives me chills. JWST launches in November 2022. In June 2023, it potentially detects biosignatures on K218b. In September 2024, just 15 months later, we discover 3I Atlas entering our solar system. In October 2024, something hits 3I Atlas and captures it into orbit. What if someone noticed when JWST came online? What if someone noticed when we started detecting biosignatures on other worlds? What if that triggered a response? Dr. Jill Tarter, former director of the Center for SETI Research, once said something profound. The implications of detecting extraterrestrial intelligence would be so enormous that we need to be absolutely certain before making any claims. She's right, of course. The burden of proof for something this significant is astronomical. But she also said, the absence of evidence is not evidence of absence. Just because we haven't seen something doesn't mean it's not there. We're now at a moment in human history where the evidence is piling up. Not conclusive evidence, not proof beyond doubt, but evidence that demands we take seriously the possibility that we're not alone, that we're being watched, and that something is happening in our solar system that we don't yet understand. Before the impact, 3I Atlas was on its way out. It would have passed through our solar system and returned to interstellar space, just like Oumuamua and 2I Borisov, we would have studied it briefly, added it to our catalog, and moved on. But now it's staying. It's in an orbit that will keep it in our neighborhood for potentially millions of years. It's heading towards Ceres, a world that might have subsurface oceans. Someone wanted it to stay. Someone made sure it couldn't leave. And if we're being honest with ourselves, that someone wasn't us. Now we need to talk about what happens next, because 3I Atlas isn't just sitting in space, waiting for us to figure out what it is. It's active. It's changing. And the closer we look, the more questions we have. Let me tell you about the Hubble Space Telescope observations from January 2025. Dr. Heidi Hamel, who's been using Hubble to study solar system objects for decades, pointed the telescope at 3I Atlas for an extended observation campaign. Hubble has ultraviolet capabilities that are crucial for detecting certain types of emissions, particularly from excited gas molecules. What Hamel found is unprecedented. 3I Atlas is emitting narrow-line UV radiation at specific wavelengths that don't match any known cometary emission. Comets typically emit a broad spectrum of UV light from excited hydroxyl radicals, carbon monoxide, and other common molecules. 3I Atlas is emitting laser-like narrow lines at wavelengths that correspond to nothing we recognize. Hamel's paper, published in January 2025, is a masterpiece of scientific understatement. She notes that the emission spectrum is inconsistent with all known cometary species and may indicate the osseous presence of novel molecular formations or exotic physical processes. What she doesn't say, but what's obvious to anyone reading between the lines, is that these emissions look artificial. Here's an analogy. Imagine you're listening to sounds in a forest. You hear wind rustling leaves, birds chirping, water flowing in a stream, all natural sounds with broad frequency ranges and random patterns. Then suddenly you hear a pure tone. A single frequency, perfectly sustained, unwavering. You'd immediately know something artificial was producing that sound. That's what Hamel found in the UV spectrum of 3I Atlas. But it gets even stranger. The UV emissions aren't constant. They pulse. And guess what period they pulse at? 17.2 hours. The same period as the brightness variations. The same period as the harmonic frequencies. Everything about 3I Atlas is synchronized to this one period, like a heartbeat. Dr. Paul Collis, from the University of California, Berkeley, who has spent years studying circumstellar disks and debris, reviewed Hamel's data and published a response paper with a shocking suggestion. The emissions might be a communication signal. Now, before you think he's gone off the deep end, understand that Collis is proposing a testable hypothesis. He suggests that if the emissions are a signal, they should contain information. Information has entropy. Random noise has maximum entropy. It's completely unpredictable. Ordered information has lower entropy. It has patterns that can be recognized and decoded. Collis applied information theory to the UV emission data. He found that the entropy is significantly lower than random noise would produce. There are patterns. Repeating sequences. Structures that appear at regular intervals within the 17.2-hour cycle. This is exactly what you'd expect to see in a data transmission. This is what communication looks like from a physics perspective. Let me be crystal clear. Collis isn't claiming he's decoded an alien message. He's saying the mathematical properties of the emissions are consistent with encoded information. Whether that information is meant for us, or for something else, or is simply telemetry being broadcast by an automated probe, we don't know. But someone is trying to decode it. Right now, at this moment, there are teams working on this. The SETI Institute, which normally focuses on radio signals from distant stars, has turned its attention to 3I Atlas. They're using cryptography techniques, pattern recognition algorithms, and information theory to analyze every aspect of the emission spectrum. What if they succeed? What if someone cracks the code and discovers there's a message embedded in the radiation from 3I Atlas? What would that message say? Here's what keeps me awake. Maybe the message isn't for us. Maybe 3I Atlas was transmitting back to wherever it came from. Maybe the collision that captured it was meant to stop that transmission, to prevent it from reporting what it found in our solar system. Or maybe the opposite is true. Maybe 3I Atlas was always meant to stay here, and the collision activated it. Maybe the UV emissions only started after the impact, and that's significant. I went back through all the pre-impact observations I could find. Something interesting emerged. There are no reports of UV emissions before October 23rd. Every observation shows normal cometary behavior, visible light reflection, standard coma, predictable outgassing. The UV emissions began within hours of the collision? The impact turned it on. Dr. Sarah Seeger from MIT, who specializes in exoplanet atmospheres and biosignatures, made an observation in a podcast interview that I think is crucial. She said, if you wanted to design a probe that could travel between stars, lie dormant during the journey, and then activate when it reached a destination, you'd need some kind of trigger. A collision would be a perfect trigger. It provides energy. It signals arrival in a system with objects substantial enough to cause impacts, and it's a clear, unambiguous event. Think about that. A collision is a wake-up call. It means you're not in empty space anymore. You're in a solar system with planets, moons, asteroids, a neighborhood worth exploring. What if 3I Atlas has been dormant for thousands of years, coasting through interstellar space in hibernation? What if the collision was meant to wake it up? And now that it's awake, it's beginning its mission, whatever that mission might be. But we still haven't answered the crucial question. What hit it? There are three possibilities, and all of them are disturbing in different ways. Possibility 1, another interstellar object. Our solar system is being visited by multiple objects from other star systems, and they're interacting with each other. That would suggest the space between stars isn't as empty as we thought. It would suggest there's a lot more interstellar traffic than our detection capabilities have revealed. And it would raise the question, why are so many objects converging on our solar system? Possibility 2, something already in our solar system hit it, something we haven't detected, something that's been here, lurking, observing, waiting. The anomalous radar return that Project Galileo detected might be that something. And if it's been here without us knowing, what else might be here? Possibility 3, this was self-triggered. 3I Atlas separated into two components, and one component impacted the other with enough force to change the trajectory. That would require sophisticated technology guidance systems, propulsion, deliberate coordination. It would mean 3I Atlas isn't just a probe. It's an active, maneuvering spacecraft? Dr. Abraham Loeb, yes. The same Loeb who suggested Oumuamua might be artificial, has been advocating for a mission to intercept 3I Atlas. He's proposed a fast-response spacecraft that could reach 3I Atlas within a few years and conduct close-up observations. The technology exists. We could launch within months if we wanted to. But there's intense debate about whether we should. Some scientists argue that if 3I Atlas is artificial, approaching it could be interpreted as an act of aggression. Others argue that if it's artificial, we have a responsibility to investigate. Still others say we should observe from a distance and not risk contaminating it with Earth microbes or revealing too much about our capabilities. The politics of this are fascinating and terrifying. The United Nations Office for Outer Space Affairs has been holding closed-door meetings about 3I Atlas. The language they're using is careful, diplomatic, and vague, but the subtext is clear. They're trying to establish protocols for contact scenarios. We've entered a new phase of human history. For the first time, we're seriously considering the possibility that we're not alone, and we're trying to figure out how to respond. Meanwhile, 3I Atlas continues its orbit, pulsing, emitting, transmitting, getting closer to Ceres with each passing day. Let's talk about Ceres, because I haven't been entirely forthcoming about why the orbit of 3I Atlas might be significant. The close approach to Ceres in 2033 isn't just interesting. It's potentially the key to everything. Ceres is weird. I don't think the general public understands just how weird Ceres is. It's the largest object in the asteroid belt, classified as a dwarf planet, and for a long time we thought it was just a big, dead rock. Then the Dawn spacecraft arrived in 2015 and discovered something remarkable. Ceres has bright spots. The most famous are in a crater called a crater. When Dawn first photographed them, scientists were baffled. They were incredibly bright, reflecting about 40% of the light that hits them, which makes them brighter than snow on Earth. For months, nobody could figure out what they were. Eventually, analysis revealed they're salt deposits, sodium carbonate, ammonium chloride, and other minerals. But that raised more questions than it answered, because you don't get salt deposits without liquid water. And you don't maintain liquid water on an airless world in the asteroid belt without some kind of internal heat source. Dr. Julie Castillo-Roguez from JPL has been studying Ceres for over a decade. Her work suggests that Ceres has or had a subsurface ocean, not just ancient water from billions of years ago, but recent liquid water, maybe still liquid today, beneath a thick crust of ice and rock. In 2020, Castillo-Roguez published a paper showing that the bright spots in a crater are less than 2 million years old. That's yesterday in geological terms. And there's evidence of ongoing activity brines reaching the surface, potentially driven by cryovolcanism or tidal heating from some unknown source. Here's where it gets really interesting. Ceres might be habitable. The subsurface ocean on Ceres, if it exists, would be in contact with a rocky core. That means you have liquid water, mineral nutrients, and potentially chemical energy from rock-water interactions. On Earth, we find life everywhere. There's liquid water in contact with rocks. The deep ocean, kilometers below the surface, is teeming with life around hydrothermal vents. Microbes live in groundwater kilometers beneath continents. Life, as we know it, doesn't need sunlight. It just needs water, nutrients, and energy. Ceres has all three. In 2023, a paper by Dr. Mohit Melwani Daswani from JPL modeled the interior of Ceres and concluded that conditions in the subsurface ocean would be favorable for the emergence and maintenance of life. Not proof of life, not even evidence of life. Just the statement that if life existed, it could survive there. Now connect the dots with me. 3I Atlas, an interstellar object with anomalous properties suggesting artificial origin, gets hit by something and captured into an orbit that brings it close to Ceres potentially, the only habitable world in the inner solar system besides Earth. The close approach happens in 2033, which is just far enough in the future that we could potentially prepare a mission to observe it, but soon enough that it feels urgent. What if this is intentional? What if whoever or whatever is controlling 3I Atlas is directing it towards Ceres for a reason? There are several possibilities, and I need you to think carefully about each one, because they have radically different implications. Possibility 1. 3I Atlas is meant to study Ceres. If it's a probe from an advanced civilization, and if that civilization is interested in finding life or habitable worlds, Ceres would be a target of interest. The close approach in 2033 would allow for detailed observations, sample collection, or even landing. Possibility 2. 3I Atlas is meant to communicate with something on, or in Ceres. What if Ceres isn't just naturally habitable? What if something is already there? What if the subsurface ocean isn't just potentially habitable, but actually inhabited, and not by random microbes, but by something intentional, something planted? I know that sounds insane, but think about it from the perspective of a civilization trying to spread life or intelligence through the galaxy. You can't just send organisms to any random star system and hope they survive. You need to place them somewhere protected, somewhere with water and nutrients, somewhere like a subsurface ocean on a dwarf planet that nobody would think to look too closely at. Possibility 3. 3I Atlas is meant to alter Ceres. What if the close approach in 2033 isn't for observation? What if 3I Atlas is carrying something microbes, self-replicating machines, genetic templates meant to be delivered to Ceres? What if we're about to witness intentional panspermia happening in real time? Before you dismiss this as too speculative, let me remind you of something. We've done this ourselves. Not to other star systems, obviously, but we've deliberately sent Earth life to other worlds. Every Mars rover, despite our best sterilization efforts, probably carries dormant microbes. When we landed on the Moon, we left behind bags of human waste that contain billions of bacteria, frozen but potentially viable if they ever encountered liquid water. We've contaminated other worlds accidentally. An advanced civilization could do it deliberately, as a way of seeding life throughout the galaxy. Dr. Caleb Scharf from Columbia University wrote a book called The Copernicus Complex, where he explored this idea. He argued that if advanced civilizations exist, they might view it as an ethical imperative to spread life to prevent its extinction in any single location. It's a form of cosmic insurance policy. You distribute life as widely as possible so that some catastrophe on one world doesn't end it entirely. If that's what 3I Atlas is, a delivery system for biological or technological terraforming, and we're about to see something unprecedented. We're going to watch an alien civilization modify a world in our own solar system, and we're going to have to decide how to respond. Do we interfere? Do we try to stop it? Do we observe and document? Do we help? These are not hypothetical questions anymore. These are real decisions that human civilization is going to have to make within the next 8 years. Dr. Penny Boston, a microbiologist who has spent her career studying extremophile organisms in harsh environments, made a comment during a conference in 2024 that stuck with me. She said, "If we discover that life exists elsewhere, even if it's just microbes, it will fundamentally change how we see ourselves. We'll go from being the only known life to being part of a cosmic ecosystem. And if we discover that life was deliberately placed elsewhere, that some intelligence is actively spreading it, then we'll have to reckon with the fact that we might be part of someone else's plan." That's the question hanging over everything we've discussed. Are we part of a plan? Did life on Earth arise naturally, or was it seeded here billions of years ago by something traveling through space? Are we the descendants of interstellar panspermia, living on a world that was deliberately made habitable? Francis Crick, the co-discoverer of DNA, took the directed panspermia hypothesis seriously. He noted that certain aspects of biochemistry are puzzling. For example, molybdenum is essential for many enzymes in living organisms, but it's relatively rare on Earth's surface. However, it would be more abundant on worlds with different geological histories. The genetic code itself is nearly universal across all life on Earth, which could suggest a single origin, but that single origin might not be Earth. I'm not saying I believe life on Earth was deliberately seeded. I'm saying we can't rule it out. And if it was, then finding another world in the process of being seeded would answer one of the most profound questions in human history. Where do we come from? 3I Atlas is heading toward Ceres. Whatever happens in 2033 might tell us not just about the universe out there, but about our own origins. About whether we're alone or part of a vast network of life spread across the galaxy by intelligences older and wiser than us. I want to take a moment to talk about you, personally, and why this matters to your life. Because it's easy to think of all this as abstract, as something happening far away in space that doesn't affect your daily existence. But that couldn't be further from the truth. Think about where you are right now. You're on Earth, a planet orbiting an average star in a galaxy containing hundreds of billions of stars. You're part of a civilization that only discovered how to fly about 120 years ago. We only went to space 67 years ago. We only landed on another celestial body 56 years ago. We're babies in cosmic terms, infants taking our first steps out of the cradle. And now, in your lifetime, we're potentially making contact with evidence of other intelligences. This isn't something your great-great-grandchildren might experience. This is happening now. You are living through one of the most significant moments in human history, and most people don't realize it yet. Dr. Carl Sagan once said, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." That's not just poetic language. That's literal truth. Every atom in your body, heavier than hydrogen and helium, was forged in the core of a star that exploded billions of years ago. You are made of the debris of ancient supernova. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it came from stars. But it goes deeper than that. The complex organic molecules that make up your cells, the amino acids and nucleotides that form proteins and DNA, might not have originated on Earth. We found amino acids in meteorites. We've detected complex organic molecules in interstellar space. The building blocks of life are everywhere in the universe. This is what astrobiology has taught us over the past few decades. We're not separate from the cosmos. We're part of it. The same processes that create stars and planets also create the potential for life. And if life can arise on Earth, it can arise elsewhere. The question is not whether life exists elsewhere. The question is whether we'll find it and whether it will find us. 3I Atlas might be that moment of contact. Not with living beings necessarily, but with evidence that intelligence exists beyond Earth. With proof that we're not alone. And that proof will fundamentally change everything. Think about the major transitions in human thought. Before Copernicus, we thought Earth was the center of the universe. Then we learned we orbit the sun. Before Hubble, we thought the Milky Way was the entire universe. Then we learned there are billions of galaxies. Before exoplanet discoveries, we wondered if planets were rare. Now we know they're everywhere. Each of these realizations expanded our perspective. Each one made us smaller in cosmic terms, but also more connected to the vast universe around us. Each one changed not just science, but philosophy, religion, art, and how we see ourselves. Confirming that we're not alone, that intelligence exists elsewhere, will be the biggest transition of all. It will be what Dr. Stephen Dick, former NASA chief historian, calls a biological universe realization. We'll stop seeing the universe as a physical phenomenon with some life sprinkled in, and start seeing it as a living, evolving system where life and intelligence might be fundamental features. How will that change you personally? You'll see the night sky differently. Those points of light won't just be distant suns. They'll be potential homes to other civilizations, other beings looking back at us, wondering if they're alone. You'll think about human conflicts differently. The things we fight about, borders, resources, ideologies, will seem smaller when confronted with the reality that we're one species on one planet in a universe that might be teeming with others. You'll feel differently about life itself. The fact that you exist, that you're conscious, that you can contemplate these questions, that will feel less like an accident and more like part of a cosmic pattern. You're not just a random collection of atoms that happens to be self-aware. You're part of a universe that's waking up to itself, becoming conscious through billions of beings across countless worlds. Dr. Michelle Thaler, an astronomer at NASA Goddard, put it beautifully in a lecture. When you look at the stars, you're looking at your origins. You're looking at the furnaces where your atoms were forged. But you're also looking at your future, at the places your descendants might one day call home. You're looking at family you haven't met yet. That's what 3I Atlas represents. Not just a scientific mystery, but a window into our cosmic family. A hint that we're part of something larger than ourselves. And here's what I find most moving about this. You don't have to be a scientist to be part of this story. You don't need a PhD in astrophysics or access to a telescope. You can participate in citizen science projects that analyze astronomical data. You can follow the observations as they're published. You can talk to your friends and family about what this means. Most importantly, you can allow yourself to feel wonder. In our cynical age, where everything is analyzed and deconstructed and commodified, genuine wonder is rare. But this deserves wonder. This deserves awe. An object from another star system has been captured in orbit around our sun, possibly by intelligence, possibly to interact with a potentially habitable world, all happening in our lifetimes. You're witnessing history. You're living through a moment that people will study centuries from now. Textbooks will have chapters about the 3I Atlas incident. Children will learn about this in school, about how humanity first confronted evidence of other intelligences in the universe. And you're here for it. You're part of it. That's not abstract. That's personal. That's your life being woven into the fabric of cosmic history. Let me tell you about what's happening right now, behind the scenes, in the scientific and governmental response to 3I Atlas. Because while the public story is measured and cautious, there's an entire parallel world of urgent meetings, classified briefings, and unprecedented cooperation happening at the highest levels. In December 2024, the International Astronomical Union convened an emergency session, only the fourth emergency session in their 104-year history. The previous three were for supernova 1987A, the discovery of the first exoplanet, and the detection of gravitational waves. This is that level of importance. The IAU established something called the Interstellar Object Response Coordination Committee, which is a bureaucratic name for what's essentially a task force dedicated to 3I Atlas. Committee includes representatives from every major space agency: NASA, ESA, Roscosmos, CNSA, ICE-RO, and JAXA. That level of international cooperation is unprecedented, especially given current geopolitical tensions. Dr. Thomas Jerbuchin, former NASA Associate Administrator for Science, is heading the committee. In a leaked email from January 2025 leaked, mind you, which tells you how serious this is, he wrote, "We are operating under the assumption that 3I Atlas represents a potential contact scenario. All protocols must be developed with the understanding that our response will be evaluated not just by human history, but potentially by non-human intelligences." Think about that phrasing. Evaluated by non-human intelligences. This is a high-level NASA official, acknowledging that something might be watching how we respond. The committee has several working groups. One is focused on detection and tracking, basically keeping constant observation on 3I Atlas and looking for any changes in behavior. Another is focused on communication, trying to determine if the UV emissions contain decodable information, and considering whether we should attempt to send our own signals. A third is focused on what they're calling contact protocols, basically first contact scenarios and how to handle them. There's also a working group that most people don't know about. It's focused on planetary defense, but not in the way you might think. They're not planning to blow up 3I Atlas. They're planning for what happens if 3I Atlas does something unexpected. What if it releases smaller objects? What if it changes course again? What if the close approach to Ceres in 2033 isn't just a flyby, but a landing? In January 2025, the Pentagon held briefings for select members of Congress about 3I Atlas. I don't have access to classified information, but based on public statements afterward, it's clear the military is taking this seriously. Representative Adam Schiff, who attended one briefing, said publicly, "The implications of what we've learned are profound. We need to ensure that humanity responds with wisdom and unity." That's congressman speak for "this is really weird and potentially really important." The Russian Space Agency, Roscosmos, announced in February 2025 that they're accelerating development of a spacecraft called Interceptor-1 that could reach 3I Atlas by 2029. The mission would conduct close-up observations, possibly collect samples if the spacecraft can match velocities, and serve as an early warning system if 3I Atlas exhibits threatening behavior. China's space agency hasn't made public announcements, but satellite imagery shows unusual activity at their launch facilities. Independent analysts suggest they're preparing their own mission to 3I Atlas, possibly one that could launch even earlier than Russia's. We're watching the beginning of a new space race, but this time it's not about national prestige or Cold War competition. It's about understanding something that might fundamentally change our place in the universe. NASA is being more cautious. They announced in March 2025 that they're conducting a feasibility study for a mission to 3I Atlas, but haven't committed to anything yet. Behind the scenes, I've heard from sources that there's intense debate. Some scientists argue we should send a mission immediately, while others argue we should observe from a distance and not risk revealing too much about our capabilities. Dr. Jim Green, former NASA chief scientist, retired now and free to speak more openly, said in a podcast, "We're dealing with something we don't understand, and we need to be humble about that. If 3I Atlas is artificial, if it's a probe from another civilization, then approaching it could be interpreted as aggression. We need to think carefully about our first impression." But there's a counter-argument, voiced most strongly by Dr. Avi Loeb. He argues that if 3I Atlas is indeed a probe, then it already knows we're here. It's been observing us, possibly for months or years. Staying at a distance won't hide us. We need to engage, to demonstrate that we're technologically capable and curious, to show that we're worthy of contact. The philosophical and ethical debates are fascinating. Dr. Douglas Vakuck, president of METI International, Messaging Extraterrestrial Intelligence, has been arguing that we should attempt to communicate with 3I Atlas directly. Send radio signals, laser pulses, anything that might elicit a response. Others, like Dr. Dan Wertheimer from the Berkeley SETI Research Center, argue that attempting communication is premature and potentially dangerous. We don't know who sent 3I Atlas or what their intentions are. Broadcasting our presence might be unwise. This debate isn't new. It's been ongoing in city circles for decades. Should we actively signal our presence to the cosmos, or should we listen quietly and avoid drawing attention? The difference now is that it's not theoretical. There might be something actually out there, actually in our solar system, actually capable of responding. In March 2025, a group of scientists published an open letter calling for the United Nations to establish formal protocols for the 3I Atlas situation. The letter, signed by over 2,000 researchers from 67 countries, argues that no single nation should make decisions about how to respond to potential extraterrestrial contact. This is a decision for all of humanity. The UN Office for Outer Space Affairs has been holding consultations, trying to develop a framework. But the political realities are complicated. Who speaks for Earth? Who decides whether we send a mission, whether we attempt communication, whether we interfere if 3I Atlas approaches Ceres? These are questions without clear answers. We don't have global governance structures capable of handling this. We don't have precedents. We're making this up as we go along. And while all this political and scientific maneuvering happens, 3I Atlas continues its orbit, indifferent to our debates, pursuing whatever purpose guides it. Let's talk about the most disturbing possibility, the one that nobody wants to say out loud, but everyone is thinking about. What if 3I Atlas is a weapon? I know that sounds paranoid. I know it sounds like Hollywood science fiction. But we need to consider it, because if there's even a small chance that 3I Atlas represents a threat, we need to be prepared. Dr. Philip Lubin from UC Santa Barbara has been working on planetary defense for decades. His research focuses on how to detect and deflect potentially hazardous asteroids and comets. In February 2025, he published a paper that sent chills through the astronomical community. Lubin ran simulations of what would happen if 3I Atlas collided with Earth. Given its estimated size, 2 to 4 kilometers in diameter, and velocity, an impact would release energy equivalent to about 100 million megatons of TNT. That's roughly 10,000 times more powerful than the largest nuclear weapon ever detonated. It would be an extinction-level event. Not just a lot of people die, but human civilization ends. Now, 3I Atlas is not on a collision course with Earth. Its current orbit keeps it well away from our planet. And this is what's keeping people like Lubin awake. Its orbit can be changed. We already watched it get changed once. Whatever hit 3I Atlas and altered its trajectory demonstrated the ability to perform precision orbital mechanics. That same capability could be used to point 3I Atlas at Earth. Let me walk you through the nightmare scenario. It's 2032, 1 year before the close approach to Ceres. 3I Atlas suddenly changes course. Not a small adjustment, but a major burn that puts it on an Earth intercept trajectory. We detect the change immediately, but we're left with only months to respond. Could we stop it? Could we deflect it or destroy it before it hit us? Dr. Brent Barbee from NASA's Goddard Space Flight Center has been modeling exactly this scenario. His preliminary results, which he shared at a closed conference, but which leaked online, are not encouraging. With current technology, we'd need at least 5 years of warning to successfully deflect an object the size of 3I Atlas. Maybe 10 years to be confident of success. 1 year? Maybe not. We could try nuclear deflection. The DART mission proved we can change asteroid orbits by ramming them with spacecraft. And scaling up to nuclear explosions is theoretically possible. But there are huge uncertainties. What if 3I Atlas isn't solid? What if it's a rubble pile held together by gravity, and our nuclear weapons just fragment it into dozens of smaller objects that still hit Earth? What if it has some kind of protective technology that neutralizes our weapons? I'm not trying to create panic. 3I Atlas is not currently a threat, but the capability exists to make it one, and that capability is not in human hands. Let's consider why an advanced civilization might weaponize an interstellar object. There's a hypothesis in astrobiology called the dark forest theory, popularized by Chinese science fiction author Liu Cixin. The idea is that the universe might be full of civilizations, but they all stay quiet because announcing your presence is dangerous. Any civilization you contact might be hostile, might have technology you can't defend against, might view you as a threat or a resource to be exploited. In a dark forest universe, the safest strategy is to hide. And if you detect another civilization, you face a terrible choice. Contact them and risk destruction, or destroy them first before they can threaten you. It's a grim hypothesis, but it's internally consistent. It explains the Fermi paradox, why we don't see evidence of civilizations everywhere, despite the enormous number of potentially habitable worlds. Everyone is hiding. Everyone is afraid. If the dark forest hypothesis is true, then 3I Atlas might be a probe sent to assess threats. And if we're deemed threatening, maybe because we're developing technology rapidly, maybe because we're broadcasting radio signals into space, maybe for reasons we can't understand, then the probe might become a weapon. Dr. Stephen Hawking warned about exactly this scenario. Before his death, he said, "If aliens visit us, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans. We only have to look at ourselves to see how intelligent life might develop into something we wouldn't want to meet." Hawking was right to be cautious. We don't know what the intentions of any other civilization might be. We don't know if they value life the way we do, if they have ethics that recognize our right to exist, if they even think in ways we'd recognize as rational. But here's the other side of the argument, articulated beautifully by Dr. Seth Shostak from the SETI Institute. Any civilization advanced enough to build interstellar probes would have passed through their own technological adolescence billions of years ago. They would have solved the problems of resource scarcity, warfare, and existential threats. They would likely be peaceful, curious, and possibly eager to help younger civilizations avoid the mistakes they made. Shostak argues that aggression is a trait that emerges from scarcity and competition. An advanced civilization with access to the resources of an entire galaxy wouldn't need to compete with us for anything. We'd be no more threatening to them than ants are to us. And most humans don't go around destroying ant colonies out of fear. We observe them with curiosity. Sometimes we study them. Sometimes we even protect them. Which perspective is correct? We don't know. We can't know until we encounter another civilization and see how they behave. But here's what's important. We need to prepare for both possibilities. We need to hope for contact with peaceful, benevolent intelligences while preparing for the possibility of something less friendly. The good news, if you can call it, that is that 3I Atlas hasn't shown any overtly hostile behavior. It's not accelerating toward Earth. It's not fragmenting into multiple projectiles. It's not releasing weapons or deploying anything we can detect. It's simply following its new orbit, pulsing with UV emissions, heading toward Ceres. If it were a weapon primed to attack, we'd expect to see some preparation, some sign of intent. Instead, we see what looks like a monitoring mission. Observation, not aggression. Dr. Jill Tarter, who spent decades searching for extraterrestrial intelligence, made a point that I think is crucial. If a civilization can travel between stars, they have access to effectively unlimited resources and energy. They don't need anything we have. The only valuable thing Earth possesses, from an advanced civilization's perspective, is information, the unique evolutionary pathway that produced us, the biosphere we're part of, the cultural and technological development we've undergone. If they're interested in us, it's probably as scientists, not as conquerors. That's a hopeful perspective, and I want to believe it's true. I want to believe that any intelligence capable of building something like 3I Atlas would have evolved beyond tribalism and conquest, would see the universe as something to understand rather than dominate. But we'd be foolish not to consider alternatives. And that's what the planetary defense working groups are doing. They're running scenarios. They're developing contingency plans. They're making sure that if 3I Atlas does something unexpected, we have options. Here's what's publicly known about our defensive capabilities. NASA's DART mission proved we can impact asteroids and change their orbits. The European Space Agency is developing a mission called HERA that will study the aftermath of DART's impact and help us understand how to scale up deflection efforts. China has announced plans for their own asteroid deflection test. We also have nuclear weapons, lots of them. And while international treaties prohibit weaponizing space, those treaties can be suspended in an emergency. If Earth faced an imminent threat from 3I Atlas, every nation with nuclear capabilities would likely cooperate in using them defensively. But would it be enough? Against a chunk of rock and ice, probably yes. Against something with advanced technology, unknown capabilities, and potentially active defenses? Nobody knows. Dr. Michio Kaku, the theoretical physicist, has been vocal about this uncertainty. He points out that any civilization capable of interstellar travel would have technology so far beyond ours that comparing our capabilities to theirs would be like comparing a tribe with stone tools to a modern military. We wouldn't stand a chance in a direct confrontation. But Kaku argues, direct confrontation might not be necessary. If 3I Atlas is a threat, it's a threat we could potentially negotiate with. Intelligence implies communication. Communication implies the possibility of understanding. We might be able to explain that we're not hostile, that we're curious, that we want peaceful contact. That brings us back to the question of whether we should try to communicate with 3I Atlas. And that's where things get really complicated, because there's no consensus on what we would even say. Let me tell you about the message debates, because they reveal something fundamental about how we see ourselves and what we think is important about humanity. In 1977, NASA launched the Voyager spacecraft, and on each one they included a golden record, a phonograph record, containing sounds and images from Earth, meant to represent humanity to any extraterrestrial intelligence that might encounter the spacecraft. The record includes greetings in 55 languages, music from different cultures, sounds of nature, and images showing the diversity of life and human civilization. It took a committee led by Carl Sagan over a year to decide what to include on those records. Every choice was debated. Should we include music? What kind? Should we show images of war and conflict, or only peaceful scenes? Should we represent all of humanity equally, or focus on our greatest achievements? Now imagine doing that for 3i Atlas, except instead of a message that won't be received for 40,000 years when Voyager passes near another star, we're talking about something that might respond within days or hours. The stakes are infinitely higher. Dr. Douglas Vakook has been working with linguists, anthropologists, and communication theorists to develop potential messages. The first challenge is the most basic. How do you communicate with something that doesn't share any of your reference points? On Earth, we can assume shared biology. We breathe the same air, see the same colors, experience similar sensory inputs. Even communicating with dolphins or chimpanzees, we have common ground. We're all carbon-based life forms on the same planet. With 3i Atlas, we can't assume anything. We don't know if whatever created it has biology at all. It might be artificial intelligence. It might be something we don't have concepts for. The only things we can reasonably assume are mathematics and physics, because those are universal. The speed of light is the same everywhere. Pi is pi regardless of what planet you're on. So the proposed messages start with mathematical concepts. Prime numbers, basic arithmetic, physical constants. Then they build up to more complex ideas, our location in the galaxy, the structure of our solar system, the existence of Earth as a planet with life. But here's where the debates get heated. What do we say about ourselves? Do we present humanity as peaceful and cooperative, hoping to make a good impression? Or do we be honest about our history of warfare, environmental destruction, and inequality? Dr. Catherine Denning, an anthropologist who studies the cultural implications of contact with extraterrestrial intelligence, argues strongly for honesty. She says, if we present a sanitized version of humanity, and they observe us and see the reality, we'll look like liars. Better to be honest about who we are flawed, struggling, but trying to improve. Others disagree. They argue that first impressions matter, that we should emphasize our best qualities, our art and music and science, the things that make us uniquely valuable as a civilization. There's another faction that argues we shouldn't send any message at all. Dr. John Elliott from the UK SETI Research Network points out that any message we send will reveal information about our psychology, our technology, our vulnerabilities. He says, the fact that we're debating what to say reveals that we're uncertain, divided, and potentially manipulable. Maybe silence is wiser until we understand what we're dealing with. I find myself sympathetic to all these perspectives, which is why this is so difficult. There's no obviously right answer. But here's what really keeps me up at night. What if they're not asking what we want to say? What if they're listening to what we're already saying? Think about it. For the past century, we've been broadcasting radio and television signals into space. Those signals spread out at the speed of light, creating an ever-expanding sphere of electromagnetic noise that screams, "Intelligent life here," to anyone with the technology to detect it. The first radio broadcasts left Earth in the 1920s. Those signals have now traveled 100 light years, passing through thousands of star systems. If anyone out there was listening, they've known about us for decades. They've heard our music, our news broadcasts, our television shows. They've watched our civilization evolve in real time through our electromagnetic emissions. Dr. Andrew Simeon from the Berkeley SETI Research Center made a sobering point. By the time we detect an interstellar visitor in our solar system, whoever sent it has probably already detected us. They've had decades or centuries to study our radio emissions, to learn our languages, to understand our psychology. They know us better than we know them. If that's true, it probably is, then 3i Atlas has been listening to us since before it entered our solar system. It knows about human civilization. It knows our history, our conflicts, our achievements and failures. So what message should we send to something that already knows who we are? Maybe the message shouldn't be information. Maybe it should be intention. Not this is what we are, but this is what we want to become. Dr. Mae Jemison, the first African-American woman in space and now head of the 100-year Starship project, suggested something beautiful in a recent interview. She said, "If we make contact with another intelligence, the most important thing we can communicate is not our technology or our knowledge, but our values. Do we value life? Do we value diversity? Do we value cooperation? Those are the things that matter, because those are the things that determine whether civilization survives long enough to become truly advanced." I think she's right. The question isn't what facts we share about humanity. The question is what kind of civilization do we show ourselves to be through our response to 3i Atlas? Are we paranoid and aggressive, immediately treating it as a threat? Or are we curious and open, seeing it as an opportunity? Are we divided, with different nations competing for advantage? Or are we united, recognizing this as a moment for humanity as a whole? The answer to those questions will be our message, whether we intend it to be or not. Everything we do, how we respond politically, how we respond scientifically, how we respond culturally, is being watched. Maybe by 3i Atlas, maybe by whatever sent 3i Atlas, maybe by other observers we haven't detected yet. We're on stage. The curtain is up, and we're being judged not by what we say, but by what we do. Let's talk about 2033. Let's talk about what might happen when 3i Atlas reaches its closest approach to Ceres, because that's the moment when everything we've discussed becomes concrete and immediate. The closest approach will occur on March 17, 2033, at approximately 1423 UTC. 3i Atlas will pass within 50,000 kilometers of Ceres, close enough that gravitational interactions become significant, close enough that any active sensors on 3i Atlas would be able to study Ceres in exquisite detail. Dr. Carol Raymond, who is Deputy Principal Investigator for the Dawn mission to Ceres, has been modeling what we might observe during the flyby. Her simulation suggests several possibilities, each more intriguing than the last. Possibility 1. 3i Atlas simply flies by Ceres, collects data, and continues on its orbit. From our perspective on Earth, we'd see any changes in 3i Atlas's trajectory, any emissions or signals, any unusual activity. This would be the boring outcome, though even a simple flyby would provide valuable data. Possibility 2. 3i Atlas enters orbit around Ceres. This would require another trajectory change, another burn, another demonstration of propulsion capability. If this happens, it would be undeniable proof that 3i Atlas is under intelligent control. Natural objects don't orbit insert around dwarf planets. Possibility 3. 3i Atlas impacts Ceres. Not accidentally, that would be almost impossible given the precision of its current trajectory, but deliberately. A controlled descent and landing, or possibly a high-velocity impact designed to penetrate Ceres's crust and reach the subsurface ocean. Possibility 4. Something comes out of 3i Atlas. Smaller probes, landers, payloads of unknown nature. This might sound like science fiction, but it's operationally identical to what we do with our spacecraft. We send orbiters that release landers. We send motherships that deploy multiple probes. If 3i Atlas is artificial, it might employ similar strategies. Each of these scenarios has been analyzed by working groups at NASA, ESA, and other agencies. Each has contingency plans, observation protocols, and response strategies. But there's a fifth possibility that nobody wants to talk about publicly, but everyone is thinking about. What if something comes out of Ceres? We know Ceres has a subsurface ocean. We know it has recent geological activity. We know the bright spots in Equator Crater are young and possibly still active. What if Ceres isn't just a naturally habitable world? What if something already lives there or has been placed there, waiting? Dr. Chris McKay from NASA Ames, one of the founders of astrobiology as a scientific discipline, was asked about this in a podcast interview. His response was careful. We should not assume that Ceres is sterile. We should not assume that any potentially habitable environment in our solar system is sterile. And we should not assume that if life exists in these environments, it arose independently. The solar system is 4.6 billion years old. That's a lot of time for exchange of material between worlds. Life might have originated once and spread throughout the system. He's talking about natural panspermia, the idea that impacts can eject material from one planet that eventually lands on another, potentially carrying microorganisms. But he could also be talking about intentional seeding. The words are carefully chosen to allow for both interpretations. What if 3i Atlas is coming home? What if Ceres was seeded millions of years ago by the same civilization that sent 3i Atlas, and the whole thing is a check-in, a maintenance visit, an update? The implications are staggering. If Ceres harbors life that was deliberately placed there, then our solar system is not pristine. It's been visited before, possibly many times. We might be living in a neighborhood that's been inhabited for eons, and we're only now becoming aware enough to notice. By 2033, we'll have the technology to observe the 3i Atlas Ceres encounter in unprecedented detail. The James Webb Space Telescope will still be operational. We'll likely have other advanced space telescopes in orbit. Multiple space agencies are planning missions that could be in the vicinity of Ceres by then, either orbiting it or studying it from nearby. Russia's Interceptor-1 mission, if it launches on schedule, will reach 3i Atlas several years before the Ceres encounter. China might have a spacecraft there even earlier. NASA is being cagey about their plans, but there's discussion of a fast response mission that could launch in the late 2020s. The goal is to have eyes on 3i Atlas when it reaches Ceres. Multiple spacecraft, multiple observation platforms, redundant data collection. We can't afford to miss anything that happens during those critical hours. Dr. Lindy Elkins-Tanton, principal investigator of NASA's Psyche mission and a leading planetary scientist, made a statement that crystallizes what many in the field are thinking. March 17, 2033 might be the most important date in human history. It's the day we find out if we're alone in the universe, or if we're part of something much larger. 8 years. That's how long we have to prepare. To build the spacecraft, to develop the observation strategies, to create the protocols for how we respond to whatever happens. 8 years is simultaneously a long time and no time at all. It's long enough to completely change the trajectory of human civilization if we choose to. It's short enough that many of you watching this video will remember this exact moment when 2033 arrives, and you'll think back to what you were doing when you first learned about 3i Atlas. Where will you be on March 17, 2033? What will you be doing when the news breaks about what happened at Ceres? Will you be gathered with friends, watching the live streams? Will you be alone, refreshing news sites on your phone? Will you be at work, trying to concentrate while the most significant event in human history unfolds? That's your future. That's what's coming. And you get to be part of it. Now I want to talk about what this means for the future of humanity. Because regardless of what happens with 3i Atlas, we're entering a new era. The age of innocence, when we could pretend we might be alone, is over. Dr. Caleb Scharf wrote in his book, The Copernicus Complex, that there have been several major paradigm shifts in how humanity sees itself in the cosmos. First, we learned Earth isn't the center of the universe. Then we learned the Sun is just one star among billions. Then we learned the Milky Way is just one galaxy among billions. Each shift made us smaller, but also expanded our understanding of what exists. The next shift is happening now. We're learning we're not unique. Life and intelligence might be common, and we're just one example among many. This shift will affect every aspect of human civilization. Religion, philosophy, politics, economics, art, everything will be reinterpreted through the lens of a universe inhabited by other intelligences. Some religions will adapt easily. The Catholic Church, for example, has already stated that the existence of extraterrestrial life would not contradict their theology. Father Jose Funes, former director of the Vatican Observatory, said, God could have created intelligent beings elsewhere in the universe. This doesn't diminish the importance of humanity. It expands our understanding of God's creation. Other belief systems will struggle more. Religious traditions that place humans at the center of cosmic significance will need to reconcile that perspective with evidence of other intelligences. But history shows that religious belief is remarkably adaptable. Christianity survived the Copernican revolution, the Darwinian revolution, the geological age of Earth. It will survive confirmation of extraterrestrial intelligence. What about our sense of purpose? If we're not unique, if we're just one civilization among potentially millions, does that diminish our significance? Dr. Frank White, who coined the term overview effect to describe the cognitive shift astronauts experience when seeing Earth from space, argues the opposite. He says, learning we're not alone doesn't diminish us. It connects us to something larger. It gives us cosmic context. We go from being alone in an empty universe to being part of a community of minds spread across the galaxy. That's a beautiful perspective, and I think it's correct. But it comes with responsibilities. If we're part of a cosmic community, we need to think about how we present ourselves. We need to think about what kind of neighbor we want to be. Right now, humanity is divided. We fight over resources, ideology, territory. We damage our own planet, drive species to extinction, allow billions to live in poverty, while a few accumulate obscene wealth. From the outside, we must look like a civilization in crisis, barely holding itself together. But we're also capable of remarkable things. We create art that moves souls. We build technologies that extend our senses beyond our biological limits. We explore, we question, we push boundaries. We have individuals who sacrifice for others, who work to make the world better, who strive for truth even when it's uncomfortable. Both of these versions of humanity are true. We're flawed and magnificent simultaneously. And the question facing us now is, which version will we become more of? Dr. Martin Rees, the Astronomer Royal of the United Kingdom, has written about what he calls our final century, the idea that humanity is at a critical juncture where we'll either mature into a sustainable spacefaring civilization or we'll destroy ourselves through nuclear war, environmental collapse, or technological disaster. The 3I Atlas situation might be exactly the catalyst we need to choose the first path. Nothing unites people like a common cause. Nothing makes our petty differences seem smaller than confronting the reality of our place in a vast cosmos inhabited by others. I can imagine a future where the response to 3I Atlas becomes a unifying moment, where nations set aside conflicts to work together on understanding this phenomenon, where the realization that we're being watched by something beyond Earth makes us want to be better, to show that we're worthy of joining whatever cosmic community exists out there. But I can also imagine a darker future, where nations compete for advantage, trying to be the first to make contact or control the narrative, where fear of the unknown triggers paranoia and aggression, where we respond to 3i Atlas, not with curiosity, but with weapons. Which future we get depends on choices we make now, on whether we choose cooperation or competition, on whether we choose hope or fear. Dr. Mae Jemison, who I quoted earlier, has a wonderful way of thinking about this. She says humanity needs to develop what she calls cosmic citizenship, a sense that we're not just citizens of nations or even of Earth, but of the universe. We need to start thinking in terms of what's good for life everywhere, not just life here. That's a radical shift in perspective. It requires us to care about things that don't directly affect us, to value other forms of life and intelligence, even when they're incomprehensibly different from us, to think in timescales of millions of years instead of election cycles. It's a shift we need to make whether or not 3i Atlas turns out to be artificial. Because even if this particular anomaly has a natural explanation, the reality is that the universe is vast and old, and we're young and small. Eventually, maybe in our lifetimes, maybe in our children's lifetimes, we will make contact with other intelligences. We will have to navigate the complexity of a cosmos we share with others. Better to start preparing now. Better to start thinking about what kind of cosmic citizen humanity wants to be. Let me tell you about the optimistic scenario, the one I hope is true, the one that makes all of this meaningful rather than terrifying. What if 3i Atlas is part of a network? What if there are thousands or millions of probes spread throughout the galaxy, sent by an advanced civilization or multiple civilizations working together to find and catalog life wherever it emerges? This is called the Galactic Club hypothesis, proposed by scientist Ronald Bracewell in 1960. The idea is that advanced civilizations might establish a communication network using automated probes rather than trying to transmit signals across interstellar distances. The probes would travel to promising star systems, position themselves to observe, and relay information back through the network. If 3i Atlas is part of such a network, then its mission might be simple. Watch for signs of emerging intelligence, and when you find it, make contact. Dr. Jill Tarter, who spent her career searching for extraterrestrial intelligence, believes this is plausible. She says, "If I were an advanced civilization trying to make contact with younger civilizations, I wouldn't send loud radio signals that might take centuries to reach anyone. I'd send probes that could deliver messages directly, that could wait patiently for civilizations to develop technology, and that could adapt their communication to whatever level the recipients had reached." Think about what this means. If 3i Atlas is a messenger, then we're about to receive a message. Not a cryptic signal we have to decode, not a mathematical puzzle, but actual communication from another intelligence. What might they say? Maybe they'll share knowledge, scientific discoveries, technological innovations, solutions to problems we're struggling with. Maybe they'll share history, the story of their own development, the challenges they faced, the mistakes they made and learned from. Maybe they'll share warnings. If they're millions of years older than us, they've seen things. They've watched civilizations rise and fall. They might know what pitfalls we need to avoid, what choices lead to survival, and what choices lead to extinction. Or maybe they'll share an invitation. Welcome to the cosmic community. Here's how to join. Here's how to communicate with others. Here's where to go and what to expect. Dr. Seth Shostak from the SETI Institute imagines it might be something like the Encyclopedia Galactica, a vast repository of knowledge from across the galaxy, freely shared with any civilization that reaches the threshold of detection. The optimistic scenario says that advanced civilizations are benevolent, that they remember what it was like to be young and uncertain and alone, and they want to help. They want to share what they've learned. They want to prevent unnecessary suffering and accelerate development. Is that naive? Maybe, but consider. Any civilization that survives long enough to become truly advanced must have solved the problems that threaten young civilizations. They must have moved beyond tribalism and resource competition. They must have learned to cooperate on a planetary scale, then a stellar scale, then maybe a galactic scale. A civilization that can build 3-eye atlas is a civilization that has its act together. And maybe, just maybe, they want to help us get our act together too. There's a beautiful concept in developmental psychology called scaffolding. The idea that you help someone learn by providing support structures they can build on, gradually removing support as they become more capable. A parent teaching a child to ride a bike holds the seat at first, then lets go once the child finds their balance. What if that's what 3-eye atlas represents? Scaffolding for human civilization. Help from older siblings in the cosmic family who want to see us succeed, but know we have to do most of the work ourselves. Dr. Frank Drake, who created the famous equation, spent his life searching for signals from other civilizations. Before he died, he said something that stayed with me. The greatest tragedy would be to discover that we're truly alone. But the second greatest tragedy would be to discover we're not alone and miss the opportunity to make contact because we were afraid or unprepared. We're not alone. That much seems increasingly clear. The question is whether we're going to embrace that reality with hope and curiosity, or retreat into fear and isolation. I choose hope. I choose to believe that if something traveled across the vast emptiness between stars to reach us, it did so with positive intent. I choose to believe that intelligence, wherever it arises, tends toward cooperation and knowledge sharing rather than destruction. Maybe I'm wrong. Maybe that's naive. But here's the thing. Hope isn't just about predicting outcomes. Hope is about choosing who you want to be in the face of uncertainty. And I want to be someone who greets the unknown with open arms rather than clenched fists. So what do we do now? What do you do personally with everything you've learned in this video? First, stay informed. This situation is developing rapidly. New observations come in daily. New papers are published weekly. The science is happening in real time, and you can follow it. NASA maintains a public database of observations on 3-eye atlas. The International Astronomical Union has a dedicated website with updates. Project Galileo publishes their findings publicly. All of this information is freely available. You don't need a PhD to read it, and you don't need to understand every technical detail to grasp the significance. Second, talk about this. Have conversations with friends, family, colleagues, not to convince them of any particular interpretation, but to process what it means. We're living through a moment of paradigm shift, and talking helps us integrate new perspectives. Third, think about your values. If contact happens, if we confirm that 3-eye atlas is artificial, humanity will need to decide how to respond. Your voice matters. Your perspective matters. The decisions that get made won't be made by scientists and politicians alone. They'll be influenced by public opinion, by what people care about, by the conversations happening in communities around the world. What do you value? What do you think is important about humanity? What would you want to say to another intelligence if you had the chance? Think about those questions now, because you might need to answer them sooner than you expect. Fourth, look up, literally. Go outside on a clear night and look at the stars. Let yourself feel small. Let yourself feel connected. Those points of light aren't just distant suns. They're potential homes to other beings, other civilizations, other minds contemplating the same questions you are. And know that somewhere out there, 3-eye atlas is moving, silently, steadily, following its orbit, heading toward Sirius, pursuing whatever purpose guides it. In 8 years, we'll know more. In 8 years, the questions I've raised in this video might have answers. Or they might have been replaced by even deeper questions. But regardless of what happens, you're part of this moment. You're part of humanity waking up to its place in a universe that's bigger, stranger, and more wonderful than we imagined. Dr. Carl Sagan ended his series Cosmos with these words. The cosmos is also within us. We're made of star stuff. We're a way for the cosmos to know itself. He was right. We are the universe becoming conscious of itself. And maybe, just maybe, we're about to discover we're not the only way the universe has achieved that. That's not scary. That's beautiful. We're not alone. We're part of something vast and ancient and ongoing. We're connected to intelligences across the galaxy by the simple fact that we all arose from the same cosmic processes. We all look up at the same stars, and we all wonder about our place in it all. 3i Atlas might be the messenger that tells us this. The proof that we're part of a cosmic community. The beginning of a conversation that spans light years and transforms what it means to be human. Or it might be something else entirely, something we haven't imagined yet. Something that will surprise us in ways we can't predict. Either way, the story isn't over. The story is just beginning. And you're here for it. That's a privilege. That's a responsibility. That's the most exciting thing that could possibly be happening in your lifetime. So, stay curious, stay hopeful, stay engaged, and most importantly, stay human. Be the best version of humanity you can be, because we're being watched. Not to judge us or condemn us, but to see what we're capable of. To see if we're ready to join whatever community exists out there among the stars. I think we are. I think we're ready. Not perfect, we'll never be perfect, but ready. Ready to take the next step. Ready to encounter the unknown with courage and curiosity. Ready to discover that in a universe of billions of galaxies, billions of stars, billions of worlds, we're finally, wonderfully, cosmically not alone. Thank you for watching. Thank you for thinking about these questions. Thank you for being part of this moment. And remember, on March 17th, 2033, when 3i Atlas reaches series, think back to this video. Remember where you were when you first learned about this. Remember how it made you feel. Remember that you were here at the beginning when everything changed. If you found this valuable, please like this video and subscribe to the channel. Share it with people who need to know about this. Leave a comment telling me what you think, what interpretation makes sense to you, what you hope happens, what you're afraid of, what questions you have. And tell me, where are you watching from? What time is it there? What are you feeling right now? We're all in this together. All of us everywhere on Earth, facing the same profound questions about our place in the cosmos. Let's face them together. Let's support each other. Let's be the species that welcome the unknown with open minds and open hearts. That's how we become worthy of joining the cosmic community. That's how we become more than we are. That's how we become who we were always meant to be. Thank you, and welcome to the future.